Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 6, How Web Apps Actually Work. Alice, we've spent 5 episodes talking about security controls and threat models. Today, we're going underneath all of that to understand the actual machine.
Right. Because every vulnerability we'll discuss from here on, injection attacks, cross-site scripting, broken access control, they all exploit specific parts of how web applications communicate. If you don't understand the conversations, you can't understand how it gets subverted.
So let's start at the beginning. I click Open Case File in my legal practice management system. What actually happens?
Your browser constructs an HTTP request. HTTP being Hypertext Transfer Protocol, the language browsers and servers use to communicate. It includes a method, get in this case. It's because you're retrieving data. A path like well API matters 452.1 documents, a set of headers including your session cookie, and it sends that across the internet to the server. The server processes it, checks who you are, checks whether you're allowed to see matter 4521, fetches the data, and sends back a response. Status code 200, which just means, okay, here's your data. Content type application, JSON, meaning the data is formatted as JSON, a structured text format, and the document list in the body.
Right, that sounds simple enough. Where does it go wrong?
Everywhere. The fundamental problem is trust. HTTP is a text-based protocol. Anyone can craft an HTTP request. You don't need a browser. You can use curl or Postman, common developer tools for sending raw HTTP requests, or a Python script, which means the server cannot assume the request came from your legitimate web interface. It might have come from an attacker who stole your session cookie, or an attacker who's just changing the matter ID in the URL to see if they can access someone else's cases.
That last one, changing the ID. I've heard that called IDOR.
Insecure Direct Object Reference. It's been in the OWASP Top 10, which we introduced in episode 3, under broken access control for years, and it's embarrassingly common. The front end only shows you your own matters, but the API endpoint doesn't actually verify ownership. It just checks, is this a valid session? If it is, here's the data. Any authenticated user can access any matter by guessing or incrementing IDs.
In legal SaaS, that's catastrophic. You'd be exposing one client's privileged litigation strategy to another client.
Or to opposing counsel if they happen to have an account on the same platform. Multi-tenant legal SaaS has to get this right at the API layer, not the UI layer.
Okay, let's talk about state. HTTP is stateless. The server doesn't remember you between requests. How does it know I'm still logged in?
Cookies. When you authenticate, the server creates a session, either a server-side record with a random ID or a signed token like a JWT, a JSON web token, a compact, self-contained token that encodes user identity, and sends it back as a cookie. Your browser stores it and attaches it to every subsequent request to that domain. The server reads the cookie and says, that's the lawyer from Morrison and Partners who logged in 4 minutes ago.
Right, yeah. And if someone steals that cookie?
They are you, full stop. That's why cookie security flags matter enormously. HTTP only means JavaScript can't read it. So even if there's an XSS vulnerability, cross-site scripting, where an attacker injects malicious code that runs in other users' browsers, the attacker's script can't grab the session cookie directly. Secure means it only transmits over HTTPS, the encrypted version of HTTP. Same site controls whether it gets sent on cross-origin requests, which mitigates CSRF attacks. Cross-site request forgery, where a malicious website tricks your browser into making requests to another site using your credentials.
What about JWTs? I see those everywhere in modern apps.
JWTs encode claims, user ID, roles, expiry, into a signed token. Think of it as a tamper-evident name badge that carries your permissions. The advantage is the server doesn't need to store session state. The disadvantage is revocation. If a user's access should be terminated immediately, they're fired, their account is compromised. You can't invalidate a JWT until it expires. You need a deny list or short expiry windows. For legal SaaS with sensitive data, I lean toward server-side sessions with aggressive timeouts. NIST 863B, a digital identity guideline from the U.S. National Institute of Standards and Technology, which we first mentioned in episode 3, recommends timeouts proportional to data sensitivity.
Let's talk about APIs. Most modern legal SaaS is a single-page app, where the browser loads the whole interface once and then updates dynamically, talking to a REST API, right?
Correct. The browser loads the application once, then communicates with the server entirely through JSON API calls. As we covered in episode 3, APIs are the programmatic interfaces services use to talk to each other. Post to create, get to read, put to update, delete to remove, those are just HTTP verbs, the action words in each request. Each endpoint is a separate attack surface. The OWASP API Security Top 10 came out in 2023 specifically because API-first architectures introduced new vulnerability patterns that the traditional Web Top 10 didn't cover well.
Like what?
Unrestricted resource consumption, no rate limiting, meaning there's no cap on how many requests someone can make. An attacker writes a script that calls your document search endpoint in a loop and downloads every document in the system. Broken function-level authorization. The front end only shows admin buttons to admins, but the API endpoint doesn't check roles, so anyone who knows the URL can call it. These are architecture-level mistakes. You can't patch them with a WAF, the web application firewall we discussed in episode 4.
Ugh. Oh. Now, the browser itself. You called it a trust boundary.
The browser is simultaneously your user's agent and a hostile execution environment. It runs your code, but it also runs third-party analytics scripts, advertising scripts, browser extensions. The same origin policy is the browser's fundamental security boundary. Scripts from your domain can't read responses from other domains. But that only works if you don't misconfigure CURSE, cross-margin resource sharing, the mechanism that controls which other websites can make requests to your server, to allow any origin, and if you don't have XSS vulnerabilities that let attackers inject scripts running in your origin.
And third-party scripts you intentionally include.
They have full DOM access within your origin, the DOM being the document object model, the browser's live representation of everything on a page. If your error tracking library is compromised, and supply chain attacks on JavaScript libraries happen regularly, the attacker's code can read everything on the page, including that privileged contract your user just opened. For legal SaaS, every third-party script is a supply chain risk that should be evaluated, pinned to specific versions, and monitored.
What about client-side validation? If I validate a form field in the browser, is that security?
It's UX, not security. The browser is the attacker's machine. They can modify or bypass any JavaScript. Client-side validation prevents accidental invalid input from legitimate users. Server-side validation prevents deliberate malicious input from attackers. You need both, but only the server-side one is a security control.
Right. So the summary is, everything runs on HTTP requests and responses. The server can't trust anything from the client. Cookies maintain state, but must be protected. APIs are individually attackable endpoints, and the browser is a controlled execution environment that's only controlled if you get the details right.
That's the machine. Every vulnerability we discuss going forward, input validation failures, injection attacks, XSS, broken auth, maps back to a specific failure in these conversations between client and server.
Next episode, input validation and sanitization. How do you verify that what the client sends is what you expect before it ever touches your database or business logic?
Until then, I'm Alice.
And I'm.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.